We can calculate the amount of heat required in the conversion of a liquid into its gas, but we have to understand a few of the characteristics of heating a liquid first. So as we heat the liquid, its temperature is going to increase linearly until we reach the point where it begins to boil. So to calculate the amount of heat in this linear region, we use the equation Q equals the mass times the specific heat of whatever liquid we're talking about times the change in temperature. Once we reach the boiling point, all of that energy that did go into raising its temperature now goes into converting the liquid molecules into the gas phase. So once we're boiling, the amount of heat is equal to the number of moles times the heat of vaporization, or the enthalpy of vaporization. So in the flat portion of our curve, when we're converting the liquid into the gas, it is the number of moles times the heat of vaporization. After all of the molecules have been converted into the gas phase, then our temperature again begins to rise linearly once it is a gas. So let's calculate the mass of water that can be vaporized at its boiling point with a certain amount of heat, so 155 kilojoules of heat. So we said if it's at its boiling point, we're in the flat portion of the curve. So the equation is Q equals the number of moles times our heat of vaporization. For water, the heat of vaporization is equal to 40.7 kilojoules per mole. So let's start with the heat that we are provided. 155 kilojoules of heat. Now we want to convert that into moles. We can use our equation, or we can use dimensional analysis. We're given kilojoules for 1 mole, so the kilojoules will go on the bottom. 1 mole of water goes on top. And now that we're in moles, we can continue our calculation using dimensional analysis. Calculate that 1 mole of water is 18.02 grams. This comes from the molar mass, so 2 times the mass of hydrogen plus the mass of oxygen. And that converts us into grams, which is what we're trying to find in the problem. So 68.6 grams of water can be vaporized using 155 kilojoules of heat. Your turn to practice. Pause the video and determine the amount of heat required to vaporize 2.58 kilograms of water at its boiling point. We are going to need the heat of vaporization of water, 40.7 kilojoules per mole. We're going to start with the 2.58 kilograms of water. So we want to get to moles. So we're going to have to go from kilograms to grams and then grams to moles. So 1 kilogram, kilograms are larger, so it takes more grams. And then using the molar mass of water, so 2 times the mass of hydrogen plus 1 times the mass of oxygen is 1 mole of water. Now that we're in moles, we can use our heat of vaporization. We want the moles to cancel, so 1 mole goes on the bottom. 40.7 kilojoules goes on top. This gives us 5,827 kilojoules of heat. However, we started with 3 significant figures, so if we're rounding for significant figures, 5,830 kilojoules of heat.